So this is a typical air conditioner. This is called window air conditioner. This now almost outdated. Nobody is using this. These were in 80s. These compressors were there. These air conditioners we call window air conditioner because it was fixed on a window, and both compressor in this everything is available here. Compressor, condenser. This is fan. This is the operator. It gets cooled air here. See here I have shown you cold air goes here, goes here, comes as cold air, and this is a temperature sensor which if the room temperature reaches 25 degrees, it stops the compressor and you will not have any cooling effect. Cooling effect will be nil. Compressor will not work. There will not be any liquid flowing here. Only once the temperature again increases say to 26 degrees, again the sensor will start the compressor and this cycle goes on. This is condenser. Here see outdoor air is sucked from here and it is thrown out. This is the hot air. So we are throwing heat from this place to outside air, outside atmosphere. So again this is a typical thing. Here air conditioner how it works. So now I hope basic how refrigerator and air conditioner works you might be knowing. Now I'll tell you types of air conditioners. So these are the types of air conditioners which slowly because of the modern requirement changes, things started changing. So here first I explained to you window air conditioner. After that they invented split air conditioner. It is not invention, it is an we can say it is only an extension of that. Means we little bit improvement there done. Split air conditioners, then package air conditioners, then VRF and VRU unit. This is called variable refrigeration flow, where this is the recent things which are now very famous in foreign countries and in India also. We are getting slowly accustomed to this. Then centralized air plant. So window air conditioner, in this I explained to you, the window air conditioner units are having both, see, all the components, namely the compressor, condenser, expansion valve, coil, evaporator and cooling coils are enclosed in a single box. So the problem in this is that all will be in one place. So when there is a problem, say window air conditioner systems are one of the most commonly used and cheapest type of air conditioners. Window air conditioners units are reliable and simple to install to keep a room cool while avoiding the costly construction of a centralized air conditioning system. Window air conditioner can be used in only small rooms, available in capacity up to 2 tons. Hence it is used for only domestic and official thing. See, then came split air conditioners. So what happened is, when the air conditioner problem comes, if it is, you think it is in conference hall. In a conference hall, when meeting is going on, if there is a problem in the compressor, in the unit, what we'll do, we cannot go and maintain it. Then experts thought that we'll try to split it. See, evaporator we put in your meeting room or in the room, and compressor, condenser, everything will be on the rooftop, and there will be pipeline which runs from top to down, so that, see, this is the one. So what we did is, see here, this is the room place. Here wherever meeting or office is going, place is there, here we will have this evaporator. Condenser, compressors, everything are mounted on the outdoor side, so that if there is any maintenance on this part, we can do it outside without disturbing the people here. So this is one type of improvement. So here outside, we will keep outside, so that evaporator will be running, fan will be running here, people will be comfortable and there will not be any major problem. So in split, advantage of this is, see, it is low initial cost, less noise and easy for installation, good alternative to ducted system. Each system is totally independent and has its own control. So disadvantage is this, there is limitation on distance between the indoor and outdoor unit. Say I told you we will keep outdoor, indoor will be inside. So the pipeline cannot go more than 100 to 150 feet length. So if it goes more than that, your efficiency of the compressor comes down. So this is the advantage. But disadvantage. So maintenance is easy, then limited air throw which can lead to possibly hot or cold spots. impact on building aesthetic, as we will be mounting so many air conditioners units on the top. Then came package unit. In this package unit, say window air conditioner and split air conditioner were coming at the tons of maximum of 2 to 3 tons. Whereas if it is beyond that, we had to go for a package unit condition. Here they are used where the cooling loads extend beyond 20 TR. All components are housed in the same box. It's be kept outside. Cooled air is thrown by high capacity blowers. So blower is, we will have ducting system, and how you might have seen in malls and hotels, or where ducts will be coming and cold air will be coming through the ducts. A unit will be kept outside the place where there will be no disturbance, and it will have its own advantages. So cold air is thrown by a high capacity blower and it flows through the duct lead through the various rooms. There are again two types of package units, air cooled and water cooled. Depending on the condition, availability of water, quality of water, they will decide whether they should go for air cooled or water cooled. This is a typical ducting system. Again, these are the advantages I told you. It is, the unit can be kept outside and single blower can be used to send the cooled air to rooms. The cost also will reduce. Maintenance can be done outside the working area. Disadvantages is, if the blower fails, we cannot send the air to entire area. So you have to stop air conditioning in that air. Loss of heat in the ducts. Ducts has to be insulated. Air leakage can be through the ducts. So then multi-split systems came. So split in, when disadvantages of split air is, they went for multi-split. So many split air conditioners. See now here we have one unit. From here multi-splits. So many evaporators are here. Only one big compressor and condensers are located outside. So this cooled gas, vapor gets cooled air outside and becomes liquid, and this liquid goes to different rooms. In all these lines, it gets evaporated, takes heat from here and comes back to compressor. This is multi-split system. Then came variable refrigerant flow. See, in variable refrigerant flow, the difference between split and variable refrigerant flow unit is that in split unit we cannot control each unit temperatures. Say each room, say if it is having 10 rooms and you send in 10 rooms, your liquid will go there and evaporate and comes back, but the control will be only in one place. So then what will happen? If there is less person, they will feel cold. If more person, they will not have the cooling effect. So this variable refrigerant flow unit came. In this unit, see here what we do is refrigerant flow is controlled in each room by sensing the particular room temperature, and there are electronic expansion valves which will control the flow of the refrigerant in the room. Required temperature only it will maintain, so that quantity also will be controlled by that. Because of that, the power consumption is reduced. See, with higher efficiency and increased controllability, the VRF system can help achieve a sustainable design. Unfortunately, the design of VRF system is more complicated and requires additional work compared to designing a conventional direct expansion system. So this is VRF unit. Here I can point out, this is the unit. From here liquid comes here, it gets evaporated in the room. From here it comes back again, goes to compressor. So this is the outdoor unit. Here in this, this is called three pipe system. In this we will have both heating and cooling. If you want heating, you can go for heating. If you want cooling, you can go for cooling. Advantage of this VRF system is, three pipe system is, that we can have heating, cooling, different temperatures in different rooms. All those can be maintained. So this is the same thing what I told you. See, history of variable refrigerant flow, VRF, also known as variable refrigerant volume. is invented in Japan by Daikin company in 1982. So they patented it as VRV. They were telling that we will control the volume of refrigerant. So since it is patented by Daikin, then people started manufacturing with a name of variable refrigerant flow. Daikin had registered the VRV term as an official trademark. All other companies use VRF for their similar HVAC system. Eventually, VRF is the more common term for this type of system, and this is the term that will be used for the rest of the articles. So advantage this one are given. So see, advantage of VRF system is, see, it saves 40% energy, because wherever what is the particular controlled refrigerant flow is allowed, so your compressor will work at different RPM, so that you will have less power consumption. That is what here energy saving claims up to 40%. Space saving, lesser noise, precise temperature control, simultaneous heating and cooling only in 3 pipes here. Heat recovery, zoned comfort. Limitation is initial cost is high, because since additional backup unit is needed. Separate fan coil unit in each room. Each room should have one fan and the operator. Large quantity of refrigerant pipe is required, and since length of pipe is more, you have to have more refrigerant filled also. So environmental concern, if this gas leaks, entire gas goes out and we have to refill it. So much it will have global warming problems, global warming and ozone depletion problems. For high-rise buildings, the system cannot be used. VRF system may be good option for buildings with multiple zones. See, these are the advantages which I told you. Heat pumps, centralized air conditioning. In like places where multiple buildings are there, we will have a chilling plant where water is cooled to 7 degrees centigrade, and that water is sent to different buildings where they will have air handling units. AHU, we call it as AHU, air handling units. In the air handling units, this cold water flows in a copper pipe, air is flown over that, so that heat transfer takes place, air gets cooled, and that air is circulated to your rooms. So these are being used in where very huge, like 165, 170, 100, 200, 300 TR loads are there. There we use these centralized air conditioning systems. Chilled water flows. See here, it consists of huge compressors that has to capacity cool the large quantity of water, having hundreds of tons capacity for air conditioning purposes. The chilled water flows to AHU, and the cooled air flows through the duct to the rooms of the air conditioning purpose. See, this is the one typical different places it can be sent. Here is the centralized air conditioning system. In centralized system, the water is cooled to 7 degrees centigrade and it is pumped to different buildings. The unit will have usually cooling towers where the heat is dissipated through atmosphere. The cooling tower will work more efficiently at places where the humidity is very low. Example, Mysore, Delhi, Bangalore, etc. The cooling tower is less efficient in places like Chennai, Mumbai, Cochin, because the humidity will be high there. The disadvantage problem is the water quality plays a vital role. The total dissolved solids of water shall be maintained within 1500 ppm. If it increases, then scale formation starts and heat transfer between refrigerant and water will not take place, hence discharge pressure of the gas increases. So wherever we go for water cooled condenser, we should have a very good quality of water. The total dissolved solids of water has to be maintained. It should be maintained below 1500 ppm. So the plant service staff shall look into these aspects, give blowdown regularly to maintain the quality of water. This chilled beam system where a localized, like in ice cream factory and all, where they require an very cooled, means they will blow air, cold air on the particular point so that it gets cooled very fast. So this is called chilled beam system. Now I talked about the air conditioning, refrigeration, types of air conditioners. Now I'll tell you about the refrigerants used in the air conditioners. This is initially when water was used. It was used in, say we call this is vapor compression system. Water was used in vapor absorption system. In vapor absorption system, water was made to boil. They used to bring down the pressure to less than 10 mm of water, so that water starts boiling, and that water gets water boils and it cools the other water, chilled water, and that water was used to be circulated. Now maintaining the that much low pressure was a problem. So then vapor compression systems came. When in vapor compression system, we wanted to have higher latent heat of a refrigerant, where it gives higher latent heat. So CFC gases were invented, that is chlorofluorocarbon. Chlorofluorocarbon, this is chlorofluorocarbons and hydrochlorocarbons, HCFCs, are early synthetic refrigerants, each containing chlorine. Because of the adverse effect of chlorine on Earth's atmosphere, stratosphere, ozone layer, use of these refrigerants is regulated by international agreement. So chlorofluorocarbon, like we call it CFCs, R11, R12, R22 up to that we call it as chlorofluorocarbon. So those gases was having more chlorine. When it was released, it was going to atmosphere and it was destroying the ozone layer. Because ozone layer is a very critical layer which was not allowing the ultraviolet rays from the sun. UV rays was controlled. Now when this started, these gases, which leaked gases, used to create depletion of ozone. Because of that, these gases, CFCs, were banned. Then HCFCs, hydrochlorofluorocarbons, hydrogen was added to that. So HCFC gases like R502, R503 and other gases were invented, and those gases were used. Those gases used to have less chlorine content in that. Now by 2030, those gases also, HCFC also has to be slowly removed from the system, and we are going for HFCs, hydrofluorocarbons. HFC blends are chlorine-free refrigerants. Blends combine two or more HFC gases, which these chlorine-free refrigerants do not contribute to ozone depletion, with the exception of having an high GWP. This is nothing but global warming potential. So when we try to reduce the ozone layer depletion, ODP, global warming potential increased. So HFC gases are having more global warming potential gases. So CO2 is considered as one, and with CO2 these global warming gases are considered. And now if you say these HCFC gases, which are having 1500 to 2500 times more than the carbon dioxide. So HFC gases also is creating problem for global warming. CFC, hydrochlorone, HFC are synthetic. HCFCs are early synthetic refrigerants, each containing chlorine. Because of the adverse effect, again I am saying. See, this is the refrigerant types and characteristics. See, R12 CFC, chemical formula is CCl2F2. So 2 chlorines are there. Because of that, it is having a GWP of 1900. R11 CFC, CCl3F 4750, R1 and 4. Like that, different gases all are having, see, all these are having CFCs. That is chlorofluorocarbon, chlorine is there. So then R113, R22, this is HCFC, hydrochlorofluorocarbon. So this is having less GWP. Then R134A, this is Now being used mostly this is the gas used. This is HFC, hydrofluorocarbon. This is having 1430. Now new gas R1234YF. This is also HFC, but this is having only 4. Global warming potential is 4. So now they are recommending this gas to be used here. Then 410A previously was used, HFC blend. This is a blend of R32 and R125, 50-50% by weight. This is 1725 is the global warming potential. So 407C is also nowadays used. That is also HFC blend. Here this is blend with 3 gases, R32, R125, R134A. The global warming is 1256. So then these natural refrigerants, these are the best one because these are having very less GWP and ODP. Ozone depletion also less, and because no chlorine here, no ozone depletion, no fluorine and hydrofluoro. So because of that, here global warming also is very less. See, natural is R744 is carbon dioxide. This is CO2. This has got only 1. Ammonia 717. This is natural refrigerant NH3. This is 0 GWP and 0 ODP. R290 that is propane, natural, but this is explosive. Propane, methane and butane are fire hazardous and explosive, that's why. But these are also having very less GWP, but these are not used much, and these two can be again brought back. These were the initial refrigerants which we were using. Now because this has got less ODP and GWP, we can come back to this system again. See, global warming potential is simplified index that estimates the potential future influence on global warming associated with different gases when released to the atmosphere. This is physical property of a particular R405 gas. This is boiling point at 1 bar, that is atmosphere is minus 46 degrees centigrade. So this gas can be used where lower temperatures like minus 30, minus 25 and all is required. There we use this. This is latent heat of property will be here. See, latent heat of vaporization is 200 kilojoules per kg. If 1 kg of gas, if it boils, it gives 200 kilojoules. So that's why we select gas which has got high latent heat property and low boiling point. Both are very, very important in selecting a refrigerant in any refrigeration system. See, again, energy consumption. Air conditioners are rated by the number of the BTU of heat they can remove per hour. Another common rating term is 1 ton. I explained to you. Room air can range from 5000 BTU to 12,000 BTU air conditioners can cool between 450 to 550 square feet of floor space. The rule of thumb is that it takes around 25 BTU to cool 1 square foot of room area. These are all for design people. So now energy efficiency. So rating based on how many BTU per hour are removed for each watt of power it draws. So we have to go for an efficient one. So how we will know? We will know only by how much heat it has removed, how much power we have put. That is nothing but we call it as COP, coefficient of performance. For room air conditioners, this efficiency rating is the energy efficiency ratio or EER. It is nothing but the energy put to cool that and the amount of heat removed. That is, both are in heat units. If you do that, we will get this energy efficiency ratio. For central air conditioners, it is called seasonal energy efficiency ratio, SEER. Say energy efficiency ratio is the ratio between the cooling capacity and the power input of the air conditioner. For example, if 1 TR 3500 watts, AC consumes 1000 watts, then the ER of the energy efficiency ratio of the air conditioner is 3.5. This is watt for watt. ACs with higher ER consumes less power. Seasonal one is in seasonal. Nowadays we go for, because each season ACs will have different power consumptions. So we go for seasonal energy efficiency ratio is also expressed in BTU per watt per hour, but instead of being evaluated at a single operating condition, it represents the expected overall performance for the typical year's weather in a given location. The SEER is thus calculated with the same indoor temperature but over a range of outside temperature from 18 degrees, because in winter it goes to 18 degrees centigrade, in summer it goes to 14 degrees centigrade. So this is total. We will find all season. That's why now they say all weather, like the tunnel altitude come. This is all seasonal energy efficiency ratio. Typical EER for residential central cooling unit is 0.875 into SEER. SEER is a higher value than EER for the same equipment, because depending on the different season it will vary. See, this is star ratings given by Bureau of Energy Efficiency. This efficiency, they, to understand how much your unit is performing well, means how much rating, so like how we give in film movies and all star ratings, like that here also star rating is there. This is given by, say, energy efficiency is 2.95 EER. So this star rating will be given on this. This is 4 star. When there is 4 star, it takes only 2.595 watts. So different ratings are given here for different thing. I think I'll end the session. I hope you all understood something. If there anything, I might have gone a little fast. If you want to have any detailed thing, you can contact your staffs. They will be having my email ID. You can contact me, or you can directly call me also. Thank you very much.